Hey golfers, it's Dave from Fit2 Golf. Today I'm doing a quick comparison between flat line oscillation and SST puring to find the most stable plane for your golf shaft. Let's get started. So a quick disclaimer, this is a real scratch the surface kind of preliminary test. It's not a very elaborate experiment, not a lot of data, but I think the results are pretty interesting. Now, the reason why you'd want to use some kind of process like flowing, flatline oscillation, or puring is because shafts are inherently slightly out of round. They're slightly oval. And if you can apply some process where you can find the most stable plane and orient that in the 12 o'clock position of the club head when you build it, you eliminate a lot of inconsistency, the shaft performs better, and can avoid some misses that are attributed to equipment rather than the golfer. I'll go over what these two processes are kind of quickly. If you want more information, there's plenty of information on the web about what flowing is or puring is. Now, I'll start with flowing, flatline oscillation. That's the procedure that I use. It's pretty simple. You clamp the shaft in a clamp. I clamp it in my frequency meter. You apply a laser to the other end. I use the Golf Mechanics weighted laser. It's 200 grams. And then you bounce or twang the club. As you bounce the club, you look at the laser and the pattern that it's projecting. And if it's round or oval, you know you haven't found the stable plane. So you loosen the clamp, turn the shaft a little bit, bounce it again, and once you're able to find the place where that laser line bounces straight up and down, you know you found the stable plane. So you mark that line, and that goes in the 12 o'clock position of the head. I take it a step further. I record the CPM at that orientation. I turn the shaft 180 degrees, record that CPM. Whatever is the stiffest, that's what goes in the 12 o'clock position. Now, the process of puring is much more elaborate. It requires a very kind of high-tech machine and software. This is not something that your average club maker is going to have on hand. Most retailers don't have it, pro shops don't have it. So it's a little bit more difficult to get done, and it does come with a cost of about $20 a shaft. The way this machine works is that it first loads and tests the shaft, and then it oscillates it in, I think, 1,000 different orientations until it finds that most stable plane. A sticker is placed on the shaft, a black line is marked on it, and you get a nice printout of what the shaft was like before testing and how puring helped to tighten up those tolerances. So for this test, I only used two shafts, both from the same manufacturer. This is the Nippon NS Pro 950GH and the Nippon NS Pro Neo, both in stiff flex. The reason I used these shafts was convenience. Someone asked me to build a couple of test clubs and wanted the shafts pured, so I thought it was a good opportunity for me to do a little comparison. So once I got the shafts, they had been pured by the Golf Works, I went through my usual process of using flatline oscillation, and I did it twice. I wanted to make sure that I didn't erroneously get the kind of same result that kind of bias. I saw where the line was and found it there. Sometimes there are two places on the shaft that seem to be the flat line point, and you need to frequency them to determine which really is. I wanted to make sure that wasn't the case. So I'll put up a picture here of the results. You'll see the blue, fancy blue painter's tape with a Sharpie line in it. That's what I found in terms of flowing, and then you'll see the white sticker with the black line. That's the puring results. So take a look. They're exactly the same. As I said, I did this twice to make sure that I didn't make an error, and you might want to jump to the conclusion and say, this proves that flatline oscillation, which is a much more accessible and cheaper procedure, is the way to go. It has the same result as puring. And I wouldn't jump to that conclusion just yet, because obviously this is a test of two shafts. But it is affirming to me that this process is validated by another method, and that the cost is an issue here. Most of the golfers that I work with, even if they have an extra $20 to spend on a shaft to have it pured, they're not going to want to. They're really happy to have me use flatline oscillation, and half the time don't even know what that is. Now, on the other hand, I'm going to say I'm a big fan of puring. I've ordered shafts for myself pured. I like it when people ask me to build clubs with pured shafts because they come already with this procedure done. It saves me the step of using flat line oscillation. And you get a nice report with it. The software generates some before and after statistics about the roundness of the shaft. Also, I'm going to say that if you've ever seen the machine work and what it does and how extensive the test is, and you get that nice report, I don't think anyone's going to say that $20 is not a good value. But if you're using shafts like I am here, these are good quality shafts, but they're $25 to $35. You're almost doubling the price when you add that $20 price tag on. Now, if you're building something with like a Tour AD or a Speeder or something from Acra, $20 is a drop in the bucket. You're going to want to make sure that that club is as perfect as possible, and spending $20 on a shaft that cost you $200 or $300 or $400 is probably a good investment. So I did this test not to declare one a winner, and again, obviously this has a very small sample size. If I were running statistics on this, the power would be not that great, but it's kind of just a preliminary way of getting some discussion about this. I know this is a shaft nerdy video, but there are a lot of other equipment geeks out there, club makers and club fitters. People like to tinker around with this stuff. So I'm curious about what your experience is and your thoughts about this. Have you used FLO? Have you compared it to Pure? Do you prefer one or the other? Do you think it's all nonsense? Let's have a discussion about this. So it's the dead of winter when I'm filming this. It's cold out. There's snow on the ground. It's still a pandemic. So I'm going to tell you, until the next time, do your best to stay positive.